Hi guys, Mrs. Thompson here. We're going to talk about ions and ionic bonding. First thing, just a reminder, in ionic bonding what's happening is a not so electronegative atom is giving their electron to a very electronegative atom. And when that happens, the one that lost the electron becomes positive, the one that gained the electron becomes negative, then the two are attracted to each other because opposites attract. They're electrostatically attracted, and they form what we call an ionic bond. That's the attraction between those two particles. There's some properties that we need to know of ionic compounds. One is that they will form a crystal lattice structure. That's just a repeating pattern of ions. So it isn't just one sodium with one chlorine. It forms in that ratio, but what ends up happening is the sodium ions, being positive, are attracting a bunch of chlorine atoms that are negative. And so you get this repeating pattern of ions, which we call a formula unit. Now over here, we have something where the formula unit isn't just 1-to-1. We have calcium fluoride. And so what you see in this formula is that for every one calcium, you have 2 fluorines that are attracted to it. And then it repeats. These are solid at room temperature. The reason for that is because this attraction is really strong. The electrostatic attraction is so strong that it takes a lot of energy to get those particles to come apart. And so they tend to be solids at room temperature, which give them a very high melting point. You have to put a lot of energy to get them to separate, and therefore the temperature at which they melt at will be higher. Okay, most of them will dissolve in water. So let's talk about that. Okay, so here table salt is being added to water. We're just going to zoom in to see what that looks like. Okay. Now the water itself is polar, and that has to do with an unequal sharing of electrons, giving it a dipole. Now that dipole is attracted to the positive ends and the negative ends of the sodium and chlorine. And so water will surround those ions and break them apart. Things that are soluble in water tend to be things like ionic compounds that have some sort of charge. When we get to covalent compounds, you'll see that it's a little different. Okay, they conduct electricity when in solution, so when it's dissolved in water, or when you melt the ionic compound. So that takes lots of energy, but you can melt them. So here is just an animation of what's going on in testing for an electrolyte. An electrolyte is something that just conducts electricity. Now here the electrons are flowing from the source through a light bulb, and we have to have a closed circuit in order for this source of electrons to keep going. So what happens here is you notice the charge in the solution is helping to carry this electron over, and it closes the circuit, and the electrons continue to flow, lighting the light bulb. Okay, next we'll talk about monatomic ions. Monatomic ions are just one atom ions. Okay, so first part, the main group elements. Those are the group A elements, the representative elements. They get their charge based on how close they are to a noble gas. Nonmetals will gain electrons, and when they do that, they become negative because their electrons will outnumber their protons. And when they do that, they're called anions. Metals are losers. They'll lose electrons and form cations. I like to memorize this by thinking of the plus sign in cations. Another trick for memorizing is this cute little cartoon, ChemCat. And he says, cations are positive. So thinking of a cat paw and being positive. Cute little joke, I think. All right. Next, talk about the formation of a cation. Here we have sodium. Sodium has 11 protons, 13 neutrons, and 11 electrons normally. That's a sodium atom. We're going to turn this into a sodium ion. Now, sodium will either lose electrons or gain electrons to be like a noble gas. Well, since it only has 1 electron in its valence shell, it'd be much easier to lose that 1 electron than to gain 7 to have 8 in its valence like a noble gas. So sodium will lose its electron to something that is more electronegative than it is, and when it does that, it gains a charge. That's because now it has 11 protons, 10 electrons. The protons outnumber the electrons, and you get that 1 plus charge. And now sodium is just like neon in terms of its electronic structure, which just gives it a little bit of stability. All right, let's talk about the group A metals. So here we have column 1A. They all have 1 valence electron, even hydrogen I'm going to refer to here. Tends to lose that 1 valence electron and become a 1 plus charge. Group 2A, well, we have to think, is it easier to lose 2 or gain 6? Well, losing 2 is going to be easier. And metals are losers, it'll be a 2 plus charge when it loses those 2. Then we have column 3 metals. Those will become a 3 plus and lose those 3 valence, because it'd be easier to lose 3 than to gain 5. All right, here is an example of a nonmetal. We have chlorine. Chlorine has 17 protons, 18 neutrons. It has 7 electrons in its valence shell. Now, in order to be like a noble gas, it needs to have 8 electrons in its valence shell. So it can do that by gaining 1 from something like sodium. And then when it does that, it has 17 protons, 18 electrons. The electrons outnumber the protons, and so you get a -1 charge. Okay, and now sodium has an electron structure just like argon. Okay, in terms of the other group A elements, and we're talking about nonmetals here, we'll go with column 7A, which is right here. These all need 1 more to be like a noble gas, so they'll all gain 1, which gives them a -1 charge. These in 6A, just need 2 more, so they do that, giving it a 2 minus charge. In 5A, they just need 3 more, so they become a 3 minus. For 4A, we usually say that they can lose 4 or gain 4. Most of the time, when we're talking about carbon and silicon, those tend to form covalent bonds over here, and then you've got some metals, so we're going to just say the Na. All right. Okay. Now, then when it comes to the transition metals. Now, the transition metals exist from underneath the staircase that separate the metals and the nonmetals, all the way to here, the rest of the D block and the F block. So there's a lot of transition metals. And the fact that they're transition metals means that their charge can change. We need to learn some that are fixed charges, that don't change. Here they are. They exist in the magic triangle. The magic triangle is what I have highlighted here. If I were you, I'd go back into your periodic table and kind of make a note of that. That's the magic triangle. Or write them down. So here they are. The ones in column 3A. The 3 in 3A. Aluminum, gallium, indium. Those are all a 3 plus charge. Then you have 2 in zinc and cadmium. Those are all 2 plus charge. And then you have silver, which is a 1 plus charge. It's important that you know that these are always that charge, and they're not variable. They don't change at all. Here are the ones that change. So I'm going to put myself over here. Okay, so the metals that are not in group 1A or group 2A or in the magic triangle have variable charges. And we need to know this because when we name them, we don't just call them by their names, we actually give them a Roman numeral to say what their charge is. So here are some of the ones that we use the most often. You have chromium, which comes in chromium 3 and chromium 2. Iron, which comes in iron 2 and iron 3. Cobalt, copper, gold, tin, and lead. You will see those very often in your problems. You need to know that they are transition metals and that they can have more than one charge. When you use them, they need to have a Roman numeral, but we'll talk about that when we do some naming later. All right. So the reason why we had monatomic ions is so that we can talk about polyatomic ions. Polyatomic ions are just a group of atoms that have a charge. So for example, you have the nitrate ion here. It has 1 nitrogen and 3 oxygens attached to it. Those are all covalently bonded. They're all sharing those electrons. And what results from all that sharing is a charge of -1. It's actually gained an electron, and now it has a -1 charge, but they all share it. Next, the word oxyanion. Oxyanion just refers to any polyatomic ion that has oxygen in it. Now, most of our polyatomic ions are oxyanions. Here's the list that you have. You should have these highlighted already, but the ones that you have to memorize are ammonium, nitrate, hydroxide, acetate, comes in 2 forms. Recognize either one, please. Cyanide, chlorate, bromate, iodate, carbonate, sulfate, phosphate, and that was it. Your list will change a little bit as we learn to change some of the ate ions into ite ions. All right, next, we need to know about the possible combinations that you can make from these cations and anions. Cations can exist as either a metal cation, so just a monatomic metal that has lost an electron to become positively charged, or the polyatomic ion ammonium can form some combinations with anions and form compounds. Then for our anions, we could have a non-metal anion. So those are all nonmetals with their monatomic. And we can have a polyatomic anion. Those are from that list that I gave you. Okay, here we're just going to take a list of ionic compounds, and we're just going to see what's involved. Look at the different combinations in the list. Okay, so we have NABR. We're going to separate cation from anion. In NABR, I have sodium metal and I have bromine nonmetal. So that is my metal plus nonmetal combination. 1 metal, 1 nonmetal. Next, I have barium and calcium. Now be careful that you remember that elements begin with a capital letter. And so that lowercase letter belongs to the capital letter B. It's not boron here, it's barium. And so barium's our metal. Chlorine, even though I have 2 of them, it's just a nonmetal. So this is a metal-nonmetal combination. And the third one, I have something different. Nitrogen's not a metal, so I can't do that. I have what's called ammonium, and that's one of the polyatomic ions that you have to have memorized. I'll draw a line after the ammonium. The ammonium is the cation here, and then chlorine is a nonmetal. So that's ammonium plus a nonmetal. This next one, I'll draw a line after the metal to separate cation from anion. Na is a metal, and then OH. Those are 2 capital letters. If it was just NaO, we would have metal plus nonmetal. But here I have OH, which is a polyatomic. It's the polyatomic ion hydroxide. Okay, and the last one you have NH4 again. That's ammonium. And then you have some more capital letters after it. So you have ammonium plus more than 1 capital letter would not give me a nonmetal. That would be a couple of nonmetals which make up a polyatomic ion. So in this last one, it's ammonium plus a polyatomic. Okay, and that ends the notes for today.